Okay, so we're talking about probability, and we are counting arrangements. Alright, so when we're talking about this, we're talking about rearranging, say, 3 cards. So 3 cards on a table. How many ways can we arrange those 3 cards?
It's 3 times 3, is it?
No. So I've got 3 cards to put on the table. How many cards can I put in the first spot? How many cards could go there?
2, 3.
3 of them. Any one of the 3 could go there.
Yeah.
But if that first one goes there, how many can go in the second spot?
2.
And the last one?
Oh, yeah, 1.
1. Okay. And then if we want to know the total number of arrangements, all we do is we multiply all of those things together, and we get 6. So there are 6 ways I can arrange those cards. This works for anything. So if we've got, say, 5 people in a race, and we want to know who comes first, second, and third.
Yeah.
I always draw a box. Like, it doesn't matter what it is. I just draw a box. So of the 5 people in the race, how many of them can come first?
5.
How many can come second?
4.
And third?
3.
So we don't have to go down to 1.
Yeah.
We only have to go as many things as we're interested in. So 5 4s are 20, and 3 makes 60.
Okay.
So there are 60 ways that, you know, gold, silver, and bronze can be awarded in that particular race.
Yeah.
Okay? This is all talking about order, where the first thing is important, and the second thing is important, and the third thing is important. Or, you know, whatever after that. So it's all about if being, say, Maegen, Michael, and Prue is different to Prue, Maegen, and Michael. So in a race, May coming first is different to Prue coming first. So this is all when we're talking about order. Now, if order didn't matter, these combinations of these 3 guys with these 3 guys, if we were playing, I don't know what something has 3 people in it. If we were playing 3-on-3 basketball,
Right.
if we were playing 3-on-3 basketball, the team of Maegen, Michael, and Prue is the same team as Prue, Maegen, and Michael.
Is that P?
No, so it's C. Order is all about P. It's a permutation.
Oh.
Okay, and we remember that because you can order a pizza. So order goes with pizza.
What's C mean?
Okay, C is just the other one.
The other one.
All right, that's
Okay.
well, you know, as long as you remember one of them, it doesn't matter what the other one's doing. So all of those other ones, if we're talking about races, they work using the P button on the calculator, permutation button. So our runners, our 5 people in a race, of when we did, you know, 5 times 4 times 3, giving us 60, because the order matters, like because we've got first, second, and third, we could also do 5 people in a race where order matters, and we're interested in what happens to 3 of them. And if you do 5p3 on the calculator, you will get 60. So when we're talking about presidents, secretaries, and treasurers, and we've got 9 people, 9 people to choose from, having, you know, Maegen as the president, or me as the president, you as the secretary, and Prue as the treasurer is different than you being the president and me being the secretary and Prue still the treasurer, because she's not important.
You're so right.
Yeah, so this is all about order because it's different. It's a different setting, a different arrangement of those 3 people. So this one we have to do 9p3. And then whatever that gives you. Okay, so they're all about order.
Do you right?
So when order doesn't matter, when we're just grouping people together, say with our 3-on-3 basketball, if we've just got 3 people, those 3 people, it doesn't matter who's this player or who's this player or who's this player, the combination of those 3 players matters. So if we had, let's say Sam, we'll do you, Sam and Prue because they're different. That's the same team as Sam, May and Prue.
Yeah.
And that's the same as, PSM. These are all the same team, and there are more. So what happens if you do, say we had, 6 people to choose from, 6 people tried out for the team,
Yeah.
and only 3 people are getting on. If we do a P, it'll do all of these as different ones because it's saying that you being the first player is different than Sam being the first player as being Prue the first player.
Yeah.
So that's why P doesn't work because these teams, these arrangements are all actually the same. So what C does, C is the same as P, but it gets rid of all of the double ups. And the amount of times it double ups, you don't really need to know this, but the way this works, it does 6P3, that's a B, but it's not going away. Anyway, 6P3, and then it gets divided by the number of ways I've repeated these things, which is 3 times 2 times 1.
Yeah.
That just works out that, basically. So this is when we're just putting people in groups. So it's more about groups.
Yeah.
Rather than like groups or teams or, things like that, where it's not first and second and third or important, next important, next important. It's all just put these things in a pile and how many piles are there. So it's all about combinations rather than permutations. So this is all about your C button on the calculator. So sometimes neither of those 2 things work. It all depends on what the question's asking. Like if we're talking about a number plate, for instance, a number plate in New South Wales that goes letter, 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 number, number, number. So this is a fair question. Like they can ask you how many number plates are possible. And so this comes down back to the boxes. So C and P, lots of kids, they jump to C and P because that answers the question for them every single time. But it doesn't in this case because, it's not like, all right, well, it's something P6 or something like that, or C6. It doesn't work that way because we're not picking out of things to make these things. We've got options. So I always come back to drawing boxes. And then you just put in what can happen in the first box. So how many things can I have for that first box?
6.
Okay, and for the second box, there are 26 letters. 26 letters.
Oh, right.
10 digits. 10 digits. So, you could have the number plate AAA 111. Okay, and if we want to know how many that is, we multiply all of those numbers together and you get a big number. That's what you do, but that will not work with a P or a C.
Yeah, that makes sense.
Okay, you have to treat each question like each question is all dependent upon its wording, and if you can't interpret the wording to know whether it's ordered or unordered or whether it's neither, then you can't really. You're not gonna answer it correctly, basically.
Yep.
Okay. All right. So if we're talking about number plates and we want, from the book, we want B, O, and 007. So out of the total, we know that there are that. So the total number of plates possible is 1,757,6,000. Okay, so there are a lot. We're not going to run out anytime soon.
Yeah.
And bond this number plate is one particular number plate out of all of them in New South Wales.
Yeah.
Okay, but let's say we don't want bond 07. We just want to start with bond, and then we don't care what the number is. How many number plates can we do with that? So these guys are fixed. I have to have a B, I have to have an O, I have to have an N.
Yeah.
But how many choices have I got
10.
for that one? 10, 10, 10. So if I want bond and then some numbers, it's just 10 times 10 times 10, which is 1,000. So there are 1,000 possibilities that way.
Yeah.
And by the same token, if I want to be really cool and I want to end with 007, and I don't care what my letters are,
Yeah. Same thing, but 26.
it's the same thing but 26. So 26 times 26 times 26. And that is 17576. Well, it's just that's 1,000, so that's that bit, and that's the start bit. Yeah, I'm just that smart.
Right.
Do that in my head.
Yeah.